So if you're dealing with a half-life problem, you should be considering this equation. And in this equation, f of t represents how much you have left over after you put in a k starting amount multiplied times an exponential rate raised to the power of how much time it spends decaying. Yeah, so, well, basically, if you have 26.8 minutes for a half-life, that means you have half of it, 7.5, left over. Start with 15. Half of it is going to be left over after those 26.8 minutes. So that's what it looks like when it's all plugged in. And now you can solve for A. So with half-life problems, always start by finding out that exponential rate. So to solve for A, you first should get the exponent piece by itself by dividing both sides by 15, because that's 15 times A. You can undo it with division. And you get 1/2 on this side equals A to the 26.8 power. So your goal is to get A by itself. The way you're going to get rid of that 26.8 is you're going to raise both sides to the 1 added 26.8 power. Raise this side to the 1 added 26.8 power. Yeah, and the reason why we do that is just because a power on top of a power multiplies. So 26.8 times 1 added 26.8 is going to give us just A to the first, which is what we want. We want to solve for A. So we'll just need a calculator for this piece. So there we got A. Now we can solve some problems here. Let's go back to the word problem. It says, how many minutes would it take for a 15-gram sample to decay and have only 2 grams remain? So f of t, the remaining amount, is 2. 15 is our starting amount. Our exponential rate is that. And then they're asking for how many minutes, so we don't know what t is in this case. So we can start first, just like we did before, get the exponent piece by itself, divide both sides by 15. And once you have the exponent by itself, the exponent piece by itself, your goal is to get t by itself, to solve for t. So somehow it's got to come down. That way you can get t equals something. The only way you can make a variable come down is by taking a logarithm. And it doesn't matter what logarithm you use, so I just tend to use natural log of both sides. Yeah, because if you take a natural log of both sides, the natural log on the right can come, the t, sorry, can come down on the right. And now you have something to solve for. Because natural log of 0.974468, that's just some decimal value in your calculator. And the same thing with this decimal value over here, natural log of 0.13 repeating. You can just plug that in the calculator. Oh, there should be an equals in between there. So to get t by itself, we can divide natural log 0.974468 from both sides. I can't write that out. That again. All those 0.97 blah 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 goes there in that scribble mark. That will get t by itself. It rounds up to 78 minutes in this case. So to answer the question, how many minutes would it take for that decay? It would take just about 78 minutes.